First one is from Nathaniel Hawthorne. And he says that easy reading is damn hard writing. Right? So it's not easy. Second quote is from Stephen King. And he says, if you want to be a writer, you must do two things above all others. Read a lot and write a lot. So I encourage you to go off and read lots of papers, do great research, and then write a lot about it. All right, thanks for your attention. I'm happy to take some questions. So I don't know if there's time for questions or, yeah? Yep. How many articles do I tend to write per year? It's not an easy thing to put a number on, and it's different for me than it would be for you, let's say. Different for me because now I have graduate students and undergraduate students doing projects with me, and so I wouldn't say that you should try to aim necessarily for a certain number of articles. People are always debating in the scientific community, you know, it's kind of publish or perish, so you should just write tons and tons of articles. I think there should be some quality in those articles too. This is very, very much an opinion type of thing. On the other hand, I think a good way to go about writing a lot is to make sure that you do a little bit every day. So if you set yourself a goal, say I'm going to write 1 page each day. I'm going to sit down for an hour and a half and try to write for that amount of time. And even if it's not writing new material, but revising things that you've already written, or reading an article and critically thinking about that article to improve your own writing, I think that's a good way to improve yourself as a writer. Yeah. Yeah. Okay, thank you.
Thank you so much, Dr. Rabbat, for your presentation. It was really great. So guys, we have a break until 11:30, and then we go on with our next speaker.
All right, so we're very excited about our next speaker, Dr. Joe Schwarcz. He's a chemistry professor at McGill. He's a renowned science writer. He's appeared in Discovery Channel, CBC, CTV, has written many books, most of them bestsellers, and we're very excited to have him here today. Please help me welcome Dr. Joe Schwarcz.
Thanks very much. Am I tethered here? As I suspect many of you know, we have a huge problem today with scientific illiteracy in the world. This ranges all the way from the humorists, from people signing petitions to ban dihydrogen monoxide. I'm sure you've heard those kind of stories. But it has very serious consequences. When people start not vaccinating their children, because they believe that vaccines cause autism. When they begin to worry about cell phones causing brain tumors. When they believe that you can treat cancer with so-called alkaline water. We're looking at a very serious situation. And it's worthwhile to talk a little bit about this because you guys are scientifically minded. But I'm sure that you do go to parties and engage people who don't know very much about science. And they probably look at you as, you know, we're some kind of a strange creature because you believe in the scientific method. So maybe we can discuss some of these things and give you some information that you can use to enlighten the heathens out there. I've been dealing with this business for a very, very long time in many ways, including being on the radio for now just over 30 years. And that allows me to kind of have my fingers on the pulse of the public. I know what they're interested in. I know what they're worried about. So I can give you some, pretty realistic stuff here. 30 years is a long time. It's a painfully long time. Of course, you can only tell because of the dial telephone here. And I don't remember the very first question that I was asked when I did my first show, but I remember the second question because it was a stunning one. It was 30 years ago. And I was kind of nervous doing this for the first time. And so I'm listening to the caller. I think I'm listening kind of carefully. And I hear him ask this rather intriguing question. You hear something like that, it kind of stuns you, and you start to have these strange anatomical juxtapositions, going through your mind. But then turned out that the caller himself was somewhat nervous, and he had been speaking very quickly, and he had forgotten a key word. The key word was golf. He was interested in golf balls. Why? As I was to find out, golfers have some strange habits. One of them, of course, is playing golf. But aside from that, they're a superstitious bunch. And many golfers will pick up the golf ball and kiss it and put it back down before whacking it. I can assure you this is not for aerodynamic reasons. I'm sure you understand the engineering here. Those dimples on the golf ball are there for a purpose. It's not a good idea to fill in with saliva. But the reason for concern here is that the gentleman was worried about pesticides that were used on golf courses at that time, as they are still used today. And this, of course, is because you don't want weeds growing on your beautiful greens. And he was concerned that there might be enough of a chemical residue there that he would transfer to his mouth from kissing the golf ball. Sort of a legitimate question. So we launched into discussion, and I sang to him the anthem of toxicology that I've done many times since then, only the dose makes the poison. And I told him, look, the chances are that the amount of pesticide residue you may have transferred to your lips is probably irrelevant, but I suggested that there were much better things in life to go around kissing than golf balls. But it was sort of an interesting introduction to how you have to deal with the public for two reasons. One, you have to really make sure that you're answering the questions that are being asked. And also that people will worry about all kinds of things. The worries may be relevant or not. In this case, I wouldn't totally dismiss this as an illegitimate concern, because let's face it, pesticides are designed to be toxic, right? That's what they do. They kill insects, they kill weeds. So it's not outside the scope of reality that there might be some issue here. But of course, it's always a question of amounts. It's a question of the dose. And this has been a theme in many of the issues that I've had to deal with over the years. In science, we constantly have to deal with numbers. But I do get some very interesting questions. Not long ago, a lady wanted to know what was the safest way to burn a laminated picture. Well, where is that coming from? Well, it turned out that there had been a divorce, and of course her tendency was to get rid of every memento of her former hubby, and she had this laminated picture. She wanted to get rid of it, and she would have really preferred throwing it into the fireplace and seeing him burn. But she did have some scientific background, and she knew that these laminated pictures were glued onto a backing of particle board, and that the particle board is glued together with urea formaldehyde resin. And she was worried that if she would throw this picture into the fireplace, it would release some formaldehyde. She knew that formaldehyde had toxic potential, and of course she worried that her former hubby would have the last laugh, and this was something that she was not willing to entertain. So we discussed this, and I said, look, anytime that there's any combustion going on, anytime that you burn wood, you burn coal, anything like that, you will produce some formaldehyde. The amount that you're adding from the laminated picture is irrelevant. But I said, look, if you want to be really environmentally conscious, why don't you hang on to that picture until there's the next toxic waste collection in your neighborhood and get rid of it then? She really liked that idea, because she said, yeah, her former husband could be classified as toxic waste. So you can see that people worry about all kinds of things. And again here too, it's not a totally irrelevant worry. there's some legitimacy to toxins being released. Another caller wanted to know if tripolyphosphate was a chemical. Well, you see, I hear this, I know immediately where this conversation is heading. Because what is she really asking? What does that question really mean? Is it dangerous? Exactly. Because in most people's mind, the word chemical is associated with toxin, poison. Not surprising. Take a look at your newspapers, take a look at magazines. Anytime that the word chemical appears, it will always be preceded by an adjective that's a pejorative. Dangerous chemical, poisonous chemical, toxic chemical, as if there were no useful chemicals. Chemicals, of course, are not good or bad. They don't make any decisions. They're just things. We make the decisions on how to use them. There's no such thing as a safe or a dangerous chemical. There are safe ways or dangerous ways to use chemicals. But of course, the worry about chemicals is what raises these kind of questions. Well, to her, tripolyphosphate was a chemical. It undoubtedly was concocted by some nefarious chemists in the lab. And of course, all that we chemists want to do is come up with new cancer-causing substances to unleash upon the unsuspecting public. Well, where had she come up against this? Reading a list of ingredients on a cleaning agent, which is not a bad cleaning agent, actually. And it's a good idea to know what's in products. So reading ingredient lists is a good thing. And she came across sodium tripolyphosphate. She wanted to know if it was a chemical. Of course, she wanted to know whether this cleaning agent was dangerous or not. So I explained to her that the tripolyphosphate here enhances the activity of the detergent because it ties up minerals in the water. That's what phosphates do. And if you have minerals in the water, they can interfere with cleaning action because they will bind to and inactivate detergents. So I explained this to her, and I told her it was an innocuous substance, and I think she bought it because after all, if you expect to find chemicals somewhere, it's in cleaning agents. That's okay. That's where they belong. She calls me back again 2 weeks later. I recognized her voice despite the panic in it. And she said that she had once again run across sodium tripolyphosphate, but this time it was on a different label, a food label. I suspect many of you will recognize this particular delicacy. This is Kraft Dinner, which also contained the sodium tripolyphosphate. So she says to me, you know, I feed my son Kraft Dinner every day, which apparently was not a problem. So she says, what is a cleaning agent doing in there? So I explained, look, actually sodium tripolyphosphate is a multi-talented chemical. It can do many different things. Yes, in the detergent, it ties up the minerals so they don't interfere with the cleaning action. Here they perform a completely different function. Phosphates enhance the rate at which water can be absorbed by starchy materials, so that it is put into here so that the macaroni cooks more quickly. So I said, look, it's in there so that when your son clamors for his daily dose of Kraft Dinner, you're up to the task and you can give it to him very quickly. I went on to suggest that, look, phosphates are ubiquitous in our environment and indeed naturally occurring in our food system. Anytime that you take a bite of meat, you're getting more phosphates than you would get from a dozen Kraft Dinners. I don't think that she was convinced by this, because chemicals like phosphates are okay in cleaning agents. You don't want them in your food. And I suspect that she had all kinds of ideas. She probably figured that the Kraft company knew that eating their product was a messy business and that it might affect sales. And they had come up with some way to clean the kid from the inside out after he was eating the macaroni. Where do they get such crazy ideas about chemicals? Well, they get them from books like this.